Hello, this is a recording of the solution for the last problem that we will be tackling for Synchronous Session 5. So dahil hindi inabot ng oras, ay gagawan ko na lang to ng pahabol na pwede niyong panoorin synchronously. So, the problem reads, a 400 Newton sign hangs from the end of a uniform strut. The strut is 4 meters long and weighs 600 newtons. The strut is supported by a hinge at the wall and by a cable whose other end is tied to the wall at a point 3 meters above the left end of the strut. Find the tension in the supporting cable and the force of the hinge onto the strut. So, this is an equilibrium problem. So this uses concepts that you can find from lecture 25. So as with any problem, we can simply start off with listing our given parameters. So what are our given? What we know the weight of the sign, which is 400 newtons. We know the weight of the strut, which is 600 newtons. We also know the length of the strut, which is 4 meters. And we know the height or distance between the hinge and the top of the string to be 3 meters. So, pag nagsasolve tayo ng problem regarding equilibrium, what we do is recall the two conditions for equilibrium. So, what are the two conditions? So, first, the sum of all the forces acting on your system must be 0. And 2, the sum of all the torques acting on your system is also 0. So if you use these two conditions, you can determine the parameters needed to solve the problem. Okay, so given these parameters and the equilibrium conditions, next step natin is to get a free body diagram of the system. So this will help us in listing the forces that we need to solve the problem. So ano ang forces natin? Let's draw a similar triangle. So here we have a triangle. Oops. Draw with touch. Okay. So we have a triangle here. So this is form. Let's not write the lengths muna. We have an unknown angle, theta. So meron tayo dito. You have a tension due to the string itself. But of course, if you have a diagonal force, pwede nating laging i-decompose ito into its x and y components. So you have t sine theta and t cosine theta. You have the weight of your sign, which is at the end of the string. So in this end, nandito si W sign. Tapos you also have the weight of the strut. Pero along this line, normally we can represent the weight of the strut as located at its center of mass. So since symmetric naman yung strut natin, or at least we assume it to be, we can just simply assign the weight of the strut to be at the middle of its length. So dahil 4 meters in total ito, this will be 2 meters. 2 meters. So ito ay 2 meters. Okay. So what's next? The sum of all the forces is 0. So ibig sabihin dapat may nagka-cancel dito sa forces natin na present currently. So there is one force that is directed to the left which means that there should be one force directed to the right to cancel this force. So let's say this is Fx. So let's say this is the normal force exerted on the rod by the wall. Tapos, to make sure that the vertical forces are also zero, let's also assign some vertical force Fy. So the next step to determine this is to sum all the vertical and horizontal components. So dun sa horizontal, I only have two components, which is my Fx and t cosine theta, which means that I can sum my x components. So x, f sub x, x lang kasi may f sub x tayo na iba. So summation of f is equal to fx. So my force to the left, my force to the right, minus t cosine theta, and equilibrium condition natin, this means na 0. Now let's go back to the force diagram. Now we have four vertical forces. You have your Fy, yung force na ina-exert ni wall para hindi siya mahulog. Tong strut. You have your W sine and W strut and your vertical tension component. So we have y is equal to summation of f is equal to yung Fy upward plus t sine theta minus the weight of my strut minus the weight of my sine is equal to 0. So next, what we want to determine is the angle theta para lang mabawasan yung mga unknowns natin kasi kailangan natin yan i-determine. We can determine this angle theta using this triangle here. So given lahat ng measurements ng lengths, side lengths ng ating triangle. So what we can do here is, again, just define our trigonometric functions. So sine theta, for example, is opposite over hypotenuse. The side opposite to the angle is 3 meters, while the hypotenuse is 5 meters. So cancel lang naman tong units, 3 over 5. We can determine the angle by taking the sine inverse of this value. And if we input this to the calculator, we should get an angle of 36.87 degrees. So, ayan, inote lang natin yung angle na yan because we'll need this later. So, we set up our two forces here. So, let's rewrite them. Again, we have sum of fx, so x component is equal to f of f sub x minus t cosine theta is equal to 0. And for the y component, we have fy plus t sine theta minus w strut minus w sine is equal to 0. So next, from here, para makagalaw tayo, let's do the summation of torque condition. So using the summation of torque condition, let's identify the torques present on the system. Anong posibleng mga forces dito na pwedeng gumawa ng torques? The forces that may possibly give us torques are the vertical forces. Kasi if you imagine, yung vertical motion dito would result in a rotation. So any of these forces may result in rotation. So using our forces, again, we have your Fy, we have your W strut, and you have your W sign. So ito yung tatlong forces na pwedeng mag-cause ng torques. So, ano yung locations nila? So here, we determine the locations of these forces as with respect to a reference point. So if we sum our torques here, we have T sub I is equal to 2 meters. Weight ng strut, kasi it's halfway here, plus 4 meters. Weight ng sign, and minus 4 meters Fy is equal to 0. So using these remaining torques here, we can calculate for the remaining terms, which is Fy. So we can write here 4 meters times Fy is equal to 2 meters times 600 newtons plus 4 meters 400 newtons. So I can get here 2,800 Newton meters all over 4 meters, which should get me a vertical force of 700 newtons. So using this vertical force, we can actually calculate now for the remaining terms. So ngayon, balik tayo dun sa ating y component ng forces, which is this equation here. So from here, I will just have to delete these terms muna. Okay. So I know my y force along the y is 700 newtons. So ibig sabihin, so 0 is equal to 700 newtons plus t sine theta minus 400 newtons minus 600 newtons. And I should get negative 300 newtons plus t sine theta. Or we can simply write 300 newtons over sine theta. So if we substitute our angle term here, we will get a tension of 500 newtons. So now that we know the tension, let's go to the x component equation. So we have Fx minus t cosine theta equals to 0. So Fx is equal to t cosine theta lang. So we should get 500 newtons times cosine 36.87 degrees. This should give us a x component force of 400 newtons. So that's the way that we can relate. That's the way we can solve this problem. So now we had the force of the hinge on the strut, which is Fx, as well as the tension force, which is yung hinahanap ng problem. So now let's relate this problem to the first item of FQ5. So dito sa FQ5, meron tayong case for letter A wherein walang mass na nakasabit doon sa meter stick. So, dahil meter stick ito, just recall that this length is 1 meter. And of course, you can use yung mga conditions mo ulit to determine the maximum angle. So you have here your sum of forces is equal to 0 and sum of torques is equal to 0. So again, yung Fx, para meron kayong three equations to work with. So you have Fx is equal to 0, sum of y is equal to 0, and sum of t, tau, is equal to 0. So using these three equilibrium conditions, you can calculate for the angle. So note lang, kapag meron akong problem like this, I can create a similar diagram, force diagram, to the previous example problem. So I have here my theta. So dito yung aking weight ng stick. So may tension ako ulit. So this is t sine theta. Tapos ito naman ay t cosine theta. So to counteract this force, there has to be a force here. So this is actually my normal force. So naiba lang yung variables ko. Ngayon, yung nag-counteract naman dun sa aking vertical forces ay not just certain force na unknown like Fy sa example kanina, but this is actually where your friction comes in. So tingnan na si static friction pumapasok. So it prevents motion kaya static. So coefficient of static friction, it's related to your force, if you recall, as mu sub s Fn. So that's how you relate your force. So since maximum angle, where before maximum angle, if that the stick can remain in equilibrium ang hinahanap, you can simply set your force of your force of static friction to be equal to U sub SFN instead of greater than or equal. So equal lang pwede na. So sa letter B naman, it's actually the same dun sa example problem natin. So you will use your three equilibrium conditions to solve for the location here, minimum value of x, where the stick would remain in equilibrium. So dito, meron akong distance x. So yung sum ng aking torques ay magiging relative to this position here. So relative dito ang measurement ko. So since this is 1 meter again, so you have here your sum ng torques due to your vertical forces. So you have here halfway yung weight ng yung stick plus. So relative to this point, you have 1 minus x times yung weight ng object mo minus lastly yung sa force of friction, you have here your 1 meter times your F sub S. So sa letter C naman, you are asked how large the static of coefficient of friction must be. Again, you can use the same equations to solve for that. Kasi at this point, you already have a given x value lang na 1 meter. So it's a matter of rewriting your equilibrium conditions. So same lang naman ulit yung similar equations ulit ang makukuha nyo to get the needed value of the coefficient of kinetic friction. Okay, so this concludes the Pahabol. So thank you for listening again, and good luck with your FQ.